Hey guys, in today's video we're going to be discussing what a permutation is. So you'll hear the word permutation a couple of times in probability or in combinatorics mathematics and discrete mathematics. It's basically a way you can work out the number of ways to rearrange something with specific conditions. So what I mean by that is, let's just start with the basic idea. How many ways can you, let's say, arrange two objects? Now that's pretty simple. If we had an object A and B, we can arrange it like this, or we can arrange it like this. We can have B and then A. So there are two options there. So this question would be, alright, there's two ways we can arrange two objects. If I asked you to say, if I said three objects, it gets a bit more tricky. So what we have here technically is A, B, C. Those are my three objects. So object A, B, and C. That's one way I can arrange them. I can also arrange it like this, A, C, B, or I can arrange it like this, B, A, C, or I can arrange it like this, B, C, A, or I can arrange it like C, A, B, or I can arrange it like C, B, A. Now, if you double check, there's one, no, that's all of them. So these are the ways you can arrange three objects. Now you can go through and check if there's any others, but these are the only ones in existence. Okay. Now, if we got something like, instead of three objects, I tell you 5 objects. How many ways can you arrange 5 objects? Well, we can start listing them out. A, B, C, D, E, F. That's 6. Let's get rid of 1. So these are objects A, B, C, D, and E. You can go through and start drawing them out, but you're going to be there for a while. So surely there's a quicker way we can think about it. So let's consider, well, our previous examples. 2 objects, there was 2 ways. 3 objects, there's 6 ways. So, and now we want to work out what 5 ways is. So consider your 5 objects, and you've got 5 placeholders. You've got first placeholder, second placeholder, third placeholder, fourth, and a fifth, etc. Okay. So what we do is, to work this out, is we think of, all right, how many objects can I place in the first placeholder? So I've got 5 objects at the time, so I can place 5 there. Now, how many objects can I now place in the fourth placeholder? Well, this is a bit weird to think about, but if you've already placed an object here, that means you only have 4 left. So the answer would be 4. How many can I place here? If you've already placed 2 there and you have 5 objects, that means you can only place 3 there. And you'll start to see where I'm going. Okay? So that's why we do this. If we multiply these numbers together, it will give us the number of ways we can arrange this object. 5 times 4 times 3 times 2 times 1 will give me 125. Okay? That will be the number of ways you can arrange 5 objects. Okay? Let's double check this with our previous examples as well. So 2 objects, I can put 2 objects here or 1 object there, multiply those, gives me 2. Now let's check 3. I can put 3 objects here, I can put 2 here and 1. Multiply those, gives me 6. So it starts to hold up. So what we're doing here is we actually invented this new operation called factorial. So this here is equal to 5 factorial, this is equal to 3 factorial, and this here is equal to 2 factorial. Okay? So this operation of multiplying from the starting number all the way down to 1 is pretty much taking the factorial of a number. So for example, if we wanted to say, alright, 100 factorial, so how many ways you can arrange 100 objects? You would go from 100 times 99 times 98, and you would go down all the way to 1. A big operation there. Okay. Now, let's consider something else. Let's say we had a specific restriction. So let's say we had a password that was 4 digits long and it had a specific order. Okay. So we've got 1, 2, 3, 4 placeholders. Okay. How many digits can I place here? Well, if you include 0, so 0 all the way up to 9, are all our digits. We can't have 10 because 10 is like 1 and 0. So you can have 10 here, you can have 9 here, and you can have 8 here and 7 here. So if you multiply those together, they'll give you the number of ways you can make a password with these digits here. Okay. Now, let's think about what we did. We know what 10 factorial is. 10 factorial is 10 times 9 times 8 all the way down to 1. Okay. We see we've got the start of 10 factorial up here. So we've got that bit there. So why don't we just write that? That's equal to 10 factorial. Now, we don't have all of 10 factorial. We're missing some of it. But do you agree 10 factorial is 10 times 9 times 8 times 7 times 6 factorial? So what we're missing here is a 6 factorial. So if I divide by 6 factorial, then that is equal to that, is it not? But what we've actually done here is 6 factorial is the same as 10 minus 4 factorial. What we've done here is taken the number of options we have and subtracted the number of placeholders. So we can rewrite it like this. So we have 10 minus 4 factorial. Okay. Now, what we're actually going to find are all these things called permutation. So let's consider a password where you've got just A, B, C, and D. How many ways can I arrange this into groups of 3? So let's keep this idea to the side though. So 10, 9, 8, 7, 10 factorial on 10 minus 6, not 6, 4 factorial. So let's consider how many ways can we arrange this into groups of 3 where the order matters. So it matters what order they go in. So AB won't be the same as BA. That's what I mean by that. So let's think about it. Well, for starters, we can rewrite this AB, C, B, C, A, and C, B, A, and then we can have C, A, B, and then we can have B, A, C, and then we can have A, C, B. So from those 3 letters, we got 6 different permutations. So permutations are like groups of things just in different orders. Now you can do this with each of these, like you can do it with these pair, and then you can do it with this pair here, but that'll take forever. What we can actually do is we can work this out straight away. So let's consider our previous problem. We had 4 things. We've got 4 things here. So we can think of it as like 4 factorial, number of ways you can arrange these, divided by the number of different like groups you can put them in. So for example, that will be, well, 4 factorial divided by 4 factorial minus 3 factorial. So in other words, we're going to get 3 times by, 4 times by 6 gives me 24. Okay, there'll be 24 different permutations where you can arrange these into groups of 3. And it's very similar to this. So it's like a pattern starting to appear here. So here we've got 10 digits and we want to put them in groups of 4. Now, these numbers here, they're not the actual digits. These are the number of digits you can place here. So there's 10 digits you can place here. This isn't the digit 10. And there's 9 digits you can place here. So these here are the number of digits, not the actual digits themselves. So we've got 10 digits in groups of 4. That's what we have here, this operation. And now we've got 4 letters into groups of 3, where we get this same calculation here. So if you have n objects and you want permutations in groups of, let's say, R, where R needs to be smaller than. So you notice how that this number here, how we've put them in groups of 3, it cannot be larger than the actual entire group. So for example, you've got 10 digits, you can't create a permutation with 11 digits. It just won't be possible. So what we can see here is we start to get this pattern here. So up here we've got the number of objects at the top, and same up here as well. So we're going to go n factorial divided by our number of objects in both of them, so 10 here and 4 there. So n minus the number of choices or groups, so in this case R, factorial. So this is the formula for permutations. So if you want to find the number of permutations in a group, you need to take the number of objects you have, find that factorial, and divide by the difference between the number of objects minus the size of groups you want them in factorial. So for example, if I have 12 people and I want 4 different permutations, I want them in groups of 4, and I want all the permutations, so I want them in groups of 4 with all the permutations. So what I mean is, that means the team A, B, C, D, that also includes team A, C, B, D, so it's the same team just in different orders. So that's what I mean by permutation. So if you're looking for combinations, you would just look for the one with these 4 letters. But permutations includes all the different arrangements. So if we had it here, you would have, alright, we'd write out our formula, NPR, and we have n factorial over n minus r factorial. So we have 12 people, so we're going to go 12p4, 12 factorial on 12 minus 4 is 8, so 8 factorial. And we go 12 factorial is the same as 12 times 11 times 10 times 9 times 8 factorial, divided by 8 factorial, and we get this system here. So 12, 11, 10, and 9. Now we could have worked this out using our very first method up here with the phone. So if we have 12 people and we want them in permutations of 4, we've got 4 placeholders. How many people we can place here? We've got 12, then we've got 11, 10, and 9. So this is where this formula really comes from, this main idea here. Okay. Yeah, that's an introduction to the idea of permutations. I'll probably do a bit more in depth on it a bit later, but if you did enjoy this video, give it a thumbs up and like and subscribe.